Good morning, everybody. Sorry for the slight delay, some technical problems. You know how this thing is in the business of flights. So welcome to this very short flight to the world of machine learning in Fabric. My name is Nico Jacobs. I'll be helping you on this flight this morning. I work for UTU, training company in Belgium, but we go throughout Europe and the Middle East to deliver training, and I'm the database guy over there. If you want to get in touch, I'm SQL Waldorf on Twitter. I'll be posting the demo script that I'll be using in a few minutes over there. So in this session, we're going to talk a little bit about machine learning. I got started with machine learning about 30 years ago, and for 28 of these 30 years, I always had to explain to people what AI and machine learning was all about. Thank God we had ChatGPT. Now everybody knows about AI and machine learning, so I can go ahead and save a bit of time on that one. The problem, though, is that ChatGPT and other things, because for the PowerPoint users in here, maybe if you ever click this button in your PowerPoint, I don't know whether you already practiced on that one, but it will go ahead and try to understand what you're saying and transcript all of this so you get live subtitling. These kind of things work without me having to train it and submit my voice or whatever. So this is generic models made with public data. Works great, but only on public data. If you want to use machine learning for instance, troubleshooting, let's say something in your production process or your price negotiations or whatever, hopefully that data is not public. Else you have a bigger problem than machine learning. So then you have to go ahead and build these models yourself. So I have a little bit of time left to briefly show you how we could go ahead and tackle such a thing, how on our own data we can build machine learning models inside Fabric. Now, if you want to go ahead and build machine learning models, let's turn off this thing again. If you want to go ahead and build machine learning models, it takes a few steps. The first step is you need to know what problem you try to solve. So we have to search for business processes that are suboptimal, because most of the time, these machine learning models allow us to do what-if analysis. What if it would change this? What if it would change that? And see what the potential outcome of these things would be. But yeah, step one, find a problem where you have enough data and where making better predictions about the future could go ahead and optimize that process. To do so, we need to find our data, and we need to understand the data. And often also we need to enrich the data. And the example that I'll be using in a few minutes, I'll be taking the example of a company who wants to send their employees to different places of the world to do consultancy or whatever. And they noticed that their customers were not happy because these employees were arriving late. And in the timesheets of the employees, they noticed that there were a bunch of flight delays causing these problems. So they want to better predict when they are going to get some flight delays over there. So then they need to understand the data that they have, their own data. But we live in these interesting times. So many companies and governments have public data. So you could go and enrich your private data also with public data to build these ideal data sets. So that's the data preparation phase that we need to do. And that's where I really love Fabric, because you have so many options in Fabric to go ahead and chew on your data, mix different data sources together. You can use the pipelines. You can go ahead and use the data flows, the Gen 2 data flows. We have notebooks for the Spark people, etc. So all these different options we have in there to do data preparation with our data right. Then comes the next step, which is building the actual model. Models are, most of the models at least, are a whole bunch of weights that are combined in some sort of exotic way, and that way make up your prediction. So it's a bunch of math, basically. The problem with it is most of these models are black box. It's not easy to understand what they're doing. So we need to properly evaluate them to see whether they're doing any good. Typically, we do that in exam style. We keep some of the data separately, and we train our model, and then we send them to this exam and say, hey, please, what would you do with this data? And then we can measure how well they do on that. And once we found a good model with that, the last step is to go ahead and deploy it. Make sure that your reports can go ahead and show these predictions as well. And for all of that, Fabric is a handy platform because it has so many of these capabilities already in it. We already know that you have your one lake where you can store your data, that you can go ahead and have all sorts of ETL tools on top of it. and that once we would be able to go ahead and predict an extra column, as soon as that column is just in one of your data sets over there, it's easy to integrate it into your reports. So I mainly want to focus over here on the modeling part of things. For that, let's switch over to a demo. Let's session timed out. Yeah, sure. I have to reload. Okay, so if you're arriving in Fabric, sorry, please. Voilà. So if you arrive in Fabric, you have all these different experiences. And I guess many of you already played with the Power BI functionality, or maybe the data engineering, the data warehousing, etc. But here you see that there is a data science experience as well. And in that experience, we mainly want to get machine learning models to make these predictions. But to get there, we'll do some trial and error. So we need experiments with which we can try all these different things. To set up these experiments, for now, the main way of doing that is via a notebook. Notebooks are basically a chunk of Python code, or yeah, you have other languages, but Python is a quite popular one. So here you see an example of such a notebook that I prepared. First thing we need to do is we need to get our data, get access to our data in there. But that's super easy as well. If you already uploaded the data in one way or another to one of these lake houses over here, you can just go ahead and look into all the different tables that you have, click a table, in my case, a table with flight delayed, say load the data to Spark, and it will already create this notebook and generate a little bit of code in it. Now, I adjusted the code a little bit. So first thing that I'm doing over here is I'm reading a bit of data with SQL in this case, but again, you have many options. So this is the data upon which I want to go ahead and make predictions. My data set has about 500,000 rows in it. And it's a very simplistic data set. I picked something small that fits on screen, but it's basically this. We have whether the flight was delayed or not, together with on which day of the week did the flight take off, at which time did the flight take off, so that's hours and minutes, and how long a flight was it, how many minutes of airtime were we expecting to get. That's, I know, very little information to predict whether a flight will be late or not, but it's just to show you how we could tackle these things. So once we have this kind of stuff, we now need to go ahead and do a whole bunch of steps upon it to get some machine learning models. And there are a lot of machine learning frameworks out there. Maybe some of you have heard of scikit-learn, or maybe some of you are doing PyTorch, etc. Over here, I'll be using SparkML, because yeah, Spark has been around for a while, it's a popular thing. But again, other machine learning models behave in a similar way. So if I go ahead and start loading this SparkML stuff, I can always ask the system, hey, what's in it? Huh? Give me a directory, give me a listing of which features I have available, which functions I have in here, etc. And there we see that this thing has classification. Classification, that's my problem. If you have a class, it's delayed or it's not delayed, you're doing a classification problem. But you'll see that they have regression in it as well. Regression is, for instance, if I would like to predict how many minutes delay will I have. So I have a continuous value that I want to predict. And you have many more in there. But if you take a closer look, we see that there are some other things as well, like pipelines, estimators, transformers. What are these? Well, if we want to build a pipeline, if we want to build a reusable set of instructions that we want to apply day after day, either to retrain the model or to apply the model on fresh data, yeah, if you build a pipeline, you have to make sure you have compatible items in it. I have a water hose at home that's just a bit of a pipeline, and if your toddler puts some marbles in there, that's not compatible with the pipeline, and everything gets stuck. So same thing over here, we have to make sure we put compatible components in there. So in the machine learning world, these components are transformers and estimators. A transformer is simple. A transformer is simply something that takes data and converts it into other data. For instance, we add a derived column, or we filter out some rows. So we get data in, we get data out. And then you can imagine, of course, that you have a bunch of these transformers one after another. They start with an input data set. The output of one becomes the input of the next one. And in that way, we transform everything. So transformers are easy. And a very typical transformer that we want is that machine learning model. Because we want to start with new observations. apply the machine learning model on top of it, and then get some predictions. So we get that same data set that we had in the input, but with an extra column that predicts whether my flight will be delayed or not. Great. Problem is, how do I get that machine learning model? I don't want to program that myself. That's the purpose of machine learning. So that's why we need something else besides transformers. And that other thing is known as estimators. An estimator also starts with a data frame, but in contrast to the transformer, the estimator produces a transformer. Or in our case, for instance, we will start with some training data for which we knew whether the flight was delayed or not. We go ahead and feed the data into an estimator, for instance, a classification tree builder or whatever, and out of it comes a classification tree or whatever other machine learning technique that you're using over there. And remember, that thing was a transformer. So estimators convert data sets into transformers. Transformers convert data into other data. And these things we can go ahead and stitch together inside a pipeline. So let's try to make that a little bit more specific. Okay, so in my data set over here, I have these 4 columns. And it was a very simple data set. And we have to first split them into features and labels. If you were at the keynote, you know, features is just an expensive name for a column. In this case, a column you want to learn from. So the features are the things from which I want to predict whether the flight will be delayed or not. In my very simple example over here, just the day of week, the departure time, and the flight, the estimated flight duration. And the label, that's a fancy name for the column that you want to predict. In my case, that column, is the flight delayed or is it not delayed? Okay, once we have these, we can now try to feed this data into our machine learning model. But there we will bump into a first problem. In SparkML, if you want to build such an estimator, they will go ahead and say, oh, I need 2 columns. 1 column with the features, 1 column with the label. So I have to squeeze all my features together in 1 single column that then has a vector of values. Yeah, that's simply the way they made these things. So good news is we do have, for instance, the vector assembler. The vector assembler is an example of a transformer that transforms a data set with a bunch of columns into a data set where you have 2 important columns, squeezing all these things together in your vectors. So I go ahead and I ask my machine learning, please give me such a vector assembler. My input columns are these 3 columns that we had over here, and create a new column called features over there. Then, just for the demo over here, I show them. In reality, you don't show them. You wait till you stitch all of them together in a pipeline. 5 minutes? Oh, I still have 7 on mine. We got started 2 minutes late. Ooh, that's going to be tough. OK, so that's my vector assembler. And over here, you see then the outcome. If you go ahead and run it, for instance, it squeezed these 3 values together in a vector over there. OK, but now we want to feed it into the machine learning. And there are other bad news or good news, dependent on how you look at it. We have a ton of classification machine learning algorithms in there. There's a huge list over there. And I picked one that is not necessarily the best one, but it's producing models that are at least readable. I picked decision trees. So a decision tree classifier is an example of an estimator. So this thing will take a data set and produce a decision tree. And a decision tree converts a data set into a data set. So here I simply tell it, go ahead and learn from all these features. That's the column that my vector assembler just made. And then go ahead and try to predict that label that we have. But here as well, another complication, these decision trees, they have a bunch of parameters. One of the nice things they do in these kind of pipeline frameworks is they make sure that every transformer and every estimator has a consistent way of telling you which parameters you have in there. For instance, how deep a tree can you build, or how do you decide when to split the tree into further nodes, etc. That's among that wide list of parameters over there. And if this was a 50-minute session, I would go ahead and walk you through all of that, but there's no time for that over here. So now we can come and build that pipeline. So here I simply tell the system, I have a pipeline. In there is that vector assembler, which must run first. And then after the vector assembler, we'll go ahead and use our decision tree classifier. We all love DTC, don't we? So that's my pipeline. And this pipeline, again, is a new estimator. Because if you feed it a data set, it will build a pipeline filled with transformers, and they will then take my raw data and apply the machine learning predictions upon it. Okay, so once I have the pipeline, the last thing that I need to do is call it. But before I can do so, remember, a model is usually a black box that is very difficult to read. So I have no other choice but to split the data into two sets. On one set, I will train the model, and then I'll keep some data apart, for which I do know whether there are delays or not. And then I can go ahead and apply the model on that one to see whether we get some correct results out of it or not. So that's the next step. You have a very simple method to split your data randomly into 70% for training data and 30% for test data. So here you have an idea about how many rows we have in there. And then I can finally call my estimator. Estimators have a fit method upon it. And that way, they return a pipeline with transformers in it. And then, of course, that one has a transform in it. So I first learn on the training data, and then I test it on that separate set that I kept aside. OK, with that, we could then get some results. And here, one of the nice things in Fabric is this thing integrates with those experiments. Remember, at the start, we've seen that there were models that we want to get, experiments to get them. Every time that you call these kind of pipelines, they return to you these experiments where you can go ahead and see all the different attempts that you had at building these things, where if you have a nice model, you can go ahead and save that model from it. But in our case, we first want to take a brief look at what kind of model came out of it. Here you see the decision tree. They're one of the very few things that produce readable models. So it's a whole bunch of if-then-else rules. And then the next step is to go ahead and test them on this test set and see which quality we get out of that one. Now, over here, I get back an accuracy of 68%. So if you're 68% sure that you could correctly predict whether there is a delay or not, I don't know whether that's good enough for your company. So you might think like, oh, let's try to improve upon this. And we could improve in a lot of different ways. The most important one in my case is I just used over there 3 stupid columns. I should add a lot more columns to it. What is the airport from where you start? What is your destination airport? Which company are you flying? Those kind of things will probably improve my model a lot. But remember, every model had all these parameters we could tweak. Yeah, I didn't try anything on that one. Remember that we had that long list of potential classification algorithms. I only picked one of them. So there's much, much more we could do. Since I only have 30 seconds left, let's ask Flamel to the rescue, or Flamel, I don't know how you pronounce this. This is some research project from Microsoft, but you can find it already. And rumor has it that it will soon be part of Fabric as well. And this thing will just more or less do things for you automatically. So over here, I can say, oh, I give you 100 seconds. I don't have 100 seconds, but I ran it already. Try to find me a good model. And this thing will now, on my data set, start trying out lots and lots and lots of different machine learning algorithms. And in the end, will report back to me like, hey, on that data set, you got the highest accuracy if you would go ahead and use, where is it over here? If you would go ahead and use this particular model, here. If you use that kind of classification thing with those kind of parameters, that's the best result that we got. So in short, we can do all these things ourselves, but we have frameworks like FlameML that can go ahead and do this work for us as well. And yeah, they're all of them part of Fabric. So to wrap up over here, machine learning, yeah, we have machine learning in Fabric. For that, you have to use notebooks for now, but maybe something else will be along the horizon later on. Pipelines are crucial. Learn about transformers. Learn about estimators. You can use the sample script that I gave you. It's 11:51 local time. We just arrived at SQL Airport with a delay of 1 minute, but that was predicted. Thank you for listening to my story. Please provide some feedback. That helps us. That helps charity. And if you want the script, get connected to my Twitter account or see me after the session. Thank you.